Hello, everyone, and welcome to this episode of Ask Android. My name is Ben Weiss. I champion app performance for Android app and library developers. Today, I'm thrilled to wrap up what has been an incredibly packed and exciting Performance Spotlight week. Over the last few days, we've taken a deep dive into tools and metrics that define the modern Android performance landscape. And today's session is all about answering your questions on everything app performance. To make sure we can answer a wide range of questions, I brought a panel of experts and engineers behind the tools to this Ask Android session. So let's get started by introducing our panel. Hi, everyone. Alice, why don't you kick us off?
Yeah, thanks, Ben. Hi, everyone. I'm Alice. I'm a developer relations engineer on Android, and I specialize in power. And what that means is that I help developers make their apps more battery efficient while making sure that they're still reliable for various use cases such as location, health tracking, and task scheduling. Can I hand it off to Carmen?
Thanks. I'm Carmen. I'm an engineer on the Android platform performance team, and I work on providing APIs and full stack platform support to help you understand and improve your app's performance. So, Christopher?
Hi, everyone. My name is Christopher. I work on the Android compilers, and I have a lot of experience optimizing apps using R8.
Hey, I'm Chris. I work on Android performance in libraries and tools. So benchmarking, baseline profiles, tracing, R8, all those fun things.
Thank you so much for introducing yourselves. With this, we have a lot of people on the live stream bringing in questions. We already have questions that we have from social media. So why don't we dive right in? One question that we hear very often is, I thought R8 is just for making my app smaller. When did that change? Christopher, would you like to answer that?
Yeah, absolutely, Ben. So I can see that this can be a bit confusing. From the compiler's perspective, nothing really changed. It's not that we've fundamentally rewritten the compiler from focusing on application size to focusing on application performance. However, we've learned the importance of optimizing your app. So this has lots of benefits in terms of application performance as well, both app startup, frame performance. We see it on reduced ANRs, things like that. So I think what has changed is really the communication. We're trying to make everyone aware of the importance of running R8 and all the additional benefits it has in addition to just application size.
Thanks a lot for that, Christopher. Yeah, basically what we have is R8 always has been that performance optimizer, but we never really talked about it. So I'm very happy that we got the chance to do this during the Spotlight Week. And I do hope that you all also take a look at improving your app's performance with R8, following the guidance that we just put out there. But instead of me talking, let's answer more questions. Another question is, why should I care to make my app more performant in the first place?
Yeah, I can speak to that one. So what we have found over time and over a variety of user studies, experiments across apps, both internally and third-party apps that we partner with, is that improving performance, improving your app startup latency, within app transition latency, jank and stutter, reducing jank and stutter, when those performance metrics improve, app usage also improves. Your users will use the app more often, they'll open it more often, they'll spend more time inside the app. We've seen this time and again with all sorts of different studies and experiments. So ultimately, you should care about performance because your users care about performance. They may not even necessarily know, they may not be able to say and put it into words, but we can see it in how they use your app. And so if you care about your users, you should also be caring about the performance of your app.
Yeah, I always say it's just the easiest feature to decide upon because you like, hey, how do I build this feature? What shape should it take? Whatever. No, performance is really easy because if you just make it faster, it's just a universal win.
Exactly.
Another thing that I like to add is we've spoken with various developers where they're like, hey, we saw like a 1% increase on this key metric that we rarely see increases of, and that's because of adopting performance metrics.
Absolutely. And why we talked so much about R8 is that we've seen in a lot of metrics, we've seen improvements between 10 to 30, up to 40% of improvement by just adopting R8 in a proper way. This is not this is about startup, ANRs, janks, or rendering issues, overall memory, CPU, basically you name all of those. R8, basically because it optimizes everything, touches a lot of these different things. You sometimes have to also take a look at how can you see all this? And what we usually recommend is, as a first step, is to look at Android vitals. And the question that comes up with that is, there's so many metrics on Android vitals. Which one should I focus on first?
Yeah, I can take that. So yes, there are a lot of metrics on Android vitals, but what we recommend focusing on is called the core vitals. And basically, these are just 4 metrics. These are user perceived ANR rates, crashes, also excessive battery on wear, and we also introduced a new metric called excessive partial Wakelocks on mobile. And what these metrics mean is that they're part of our technical quality bar, and they can impact your visibility on the Play Store. Once you have gotten these metrics really solid and solidified and made sure that you're not exceeding over a threshold, then you can start to look at all the various metrics that we provide outside of that, including rendering, stability, and app startup time, and look to see how you can improve there. The other thing I would like to note is that this is also part of a blog post that we recently published as part of Day 4. It's called Leveling Your Performance, a performance guide for your performance journey. And I would highly recommend that you check it out.
I was so happy to see you coming up with this and putting all of those together, Alice. It's an awesome post, and thanks for bringing the things together for App Vitals as well. This is a very good starting point, and I think it's on the first level is talking about App Vitals. One of the further levels, we talk about Perfetto, and some people find it hard to convince engineers to actually use Perfetto. So, what do you recommend in that case?
I love to talk about Perfetto. Let me jump in on this one. Perfetto is a very cool and unique tool. A lot of app metrics and logging and maybe within process tracing will tell you what happened in your app and maybe how long it took. But it can't necessarily, or it can't usually tell you why something took as long as it did. Since Perfetto is a full picture of everything that's happening on the system during your recording, you can use a Perfetto trace not just to understand how long something took, but why it took that long. What was slowing it down? Where exactly was that time spent? So one way to convince people who are a little bit skeptical of Perfetto is to make sure they understand the difference between what Perfetto gives you and what you maybe already have in terms of logging or within app tracing. So that's one big thing that I would tell your friend. The other is that it is true, it causes a lot of people hesitation that looking at a Perfetto trace, when you take a trace, you open it up in Perfetto UI, there's a lot there, and it is pretty intimidating. You can get a long way through, like a big leg up on understanding the trace and becoming really comfortable with it by watching someone else use Perfetto. The Perfetto team has recently updated their documentation at docs.perfetto.dev. I think it's under visualization. They've added some screen recordings and walkthroughs of people navigating traces. But honestly, what I would really recommend, if you have someone, if you're on the same engineering team as someone else, to take a trace of your app that has the context of things that that they're familiar with, that you're doing within your app. Take a look at what is going on during those user journeys and do that with your friend. Do that with your skeptical friend who isn't sure of the value of Perfetto. And that can really open people's eyes up to, take away the maybe intimidation factor of looking at all that data at once when they see someone navigating through that data and kind of point them to where to look, where to draw their eye, where is the valuable information in there. Once they are taking a look at some user journeys that they're familiar with in the app, but with that X-ray view that is Perfetto, I'd be really surprised if they're not convinced. That can be so useful.
And especially with that domain specificity, right? Like, hey, my app has this, these 1 or 2 particular important components that I know are doing things asynchronously, or I know that are doing things that are potentially expensive, but just seeing that laid out right in front of you on a timeline is so powerful to both build and question your intuition of how long things should take and whether there's opportunity there.
Yeah, I kind of want to jump in with a small anecdote from R8. I'm sure all of you that use R8 are aware that adopting R8 can cause your build speed to regress. And this is something we take very seriously. Quite recently, we added support in R8 for generating Perfetto traces from the compilation. And it gave us so many insights into the build, many of which were quite easy to deal with. And on some benchmarks, we saw like a 25% improvement in build speed. I'm not saying that sort of generalizes to all apps, but we're seeing really good benefits from a relatively small investment, I would say.
Another suggestion I have is you have the ability to create SQL queries within Perfetto. And what I like to do is write like a SQL query for some of the things that I care about, such as Wakelock usage or battery life, and send it over to some coworkers so that they can try it out and see the results very quickly.
And you can always commit those as macro benchmark metrics as well.
Yeah, for sure.
Also, I know there's like a lot of things going on. We're all super excited about Perfetto. Carmen did a video series a little while back, Math Skills Performance Debugging. And also one of the engineers on the performance team working with Chris Rahul has been giving a presentation at DroidCon in London where he dove into Perfetto. So if you don't have the expert in your team, he can kind of guide you through some of those things. Carmen can guide you through some of those things as well. And don't worry in the first place, it's okay to be a bit overwhelmed by it. Once you understand what it does, it is an extremely powerful tool. We have a couple of questions from the live stream already. And I would encourage everybody to just ask your questions in there because we really want to answer those as well. Currently, we're going through a couple that we collected from social media beforehand, from other YouTube comments. But please make sure to use the chat. That's what we're here for. We want to answer your questions, and we would love to basically pass you a mic so we can answer what's going on in here. Diving a bit upwards from Perfetto itself, I have a question, and that is there a strategy for understanding the impact of performance changes?
Yeah, so I'll take this. So the very first thing that I would always do is there's kind of a hierarchy here: local tracing, benchmarking, and field metrics. If you use local tracing to just compare before and after, that's a really easy starting point, but you may not have a whole lot of trust in that. Compilation on device on Android is complicated, and it's very easy to see things like just-in-time compilation changing the performance benefits that you'll see. So that's why we recommend benchmarking where possible for important performance changes. You don't have to write a benchmark for every performance change, but if you have a benchmark for your core user interactions of your app, then hopefully if you're making a big improvement to one of those, or if you add one of those to your benchmark suite, you can see that. But then of course, benchmarking is only going to be on one or two devices. The really important thing is seeing those in field metrics at the end. But of course, you're trading off latency there for trustworthiness in those metrics.
I'd like to jump in on that just to emphasize one point, which is the value of the macro benchmark testing infrastructure. Like Chris said, there are a lot of things that the Android platform does to improve the performance of your app over time, such as applying profiles, profile-based compilation, things like that. And what that can mean in one-off testing is that you may not be testing exactly the precisely same configuration. If you run build your app, a few times in a row to test and compare between them. We've spent a lot of time in the macro benchmark test setup to make sure that you can test apples to apples every time. And so that can really take a lot of the mental load off of comparison testing to use macro benchmark.
Yeah, macro benchmark is one of the foundational things that you do when you test performance locally. We also have a couple of new things that come up in the field. And there's a question from the chat that I would like to ask. I'm just going to read it out. When using the Profiling Manager API, is there any performance impact of recording the traces? So would startup time be impacted by adding the traces for production users?
Thank you so much to whoever asked this question. I'd love to talk about this. The short answer is maybe. Depending on the type of tracing you're doing, there can be a performance impact. Standard Perfetto traces, system traces, have a very low performance impact. We test this pretty regularly. We keep our thumb on the pulse of the impact of system traces, and it's very low. Other types of traces that are provided by profiling managers, such as stack sampling and heap dumps, do have a little bit of a higher impact. That said, within Profiling Manager, we have a rate limiter that reduces that across your fleet of users will minimize the impact by only taking these traces from a relatively small amount of users. So we have a pretty low cap on the amount of traces that we allow Profiling Manager to collect per process and also across the entire system. So every individual device will only has a cap on the impact of any tracing that is done with Profiling Manager over every, I think it's, day and week and so forth. So you may see a very small impact. It's not impossible, but over all of your users, it should be very safe to use. You would not expect to see an overall shift. It would be very low, sampled at a very low rate.
Thanks a lot, Carmen.
Yeah, and I would say even if it was like on average, it's going to be far, far less than 5% or something like that. But even if it was 5%, I would happily pay that because of the kinds of things that you can find, and because you can get that back by optimizing things.
Absolutely.
And if you find this to be a problem, you know where you can find us.
Yes, please tell me.
Yeah, please just tell us. We also have the issue tracker. We monitor that very closely. You want to see what's going on. You can find us on quite a few different social media platforms, and you can just bring up those questions and those concerns that you have as feedback. Because if there's something that is an actual valid problem for you, we want to help to solve it. That's what we're here for.
One thing I'd also just like to add, I'm sorry, just for Profiling Manager, the impact of collecting a system trace is so low that we have added functionality within Profiling Manager to run background system traces sampled across your device at a low frequency. I think it's about, right now it's configured to be about 30 minutes a day-ish. We are comfortable doing that because the overhead of system tracing is so low. And there is some new functionality in Profiling Manager that lets you request if certain interesting events happen during that sampling trace. So this is really key for potentially collecting traces of really difficult to reproduce events like ANRs. If we're taking a background trace at the time that your app ANRs, we collect that trace and send it over to you. So this is a little bit different from the overhead, but just as a from the overhead question, but just to emphasize that the overhead is so low that it is very reasonable to collect these sampling traces in exchange for that good data. That's something that we're doing. And if you are interested in using this tool, those ANR traces are very interesting data to look at.
And ANR is one of those very spooky words. And if you get the possibility to find out what's going on in the field with an ANR, I think there's quite a lot of people would pay a high price for that. And if the price is a very low performance hit, maybe just, and that's already like a really good thing to pay for. Let's go on to the next question from the chat. There's a lot of coming in, so let's try and move a bit quickly with those. So I'm just going to read this. How do you evaluate the performance cost of third-party SDKs before integrating them? How do you recommend isolating slow startup blockers in general when using multiple SDKs, when multiple SDKs initialize? Chris, would you like to talk about that? Oh, you're muted.
I am indeed. So I would say that the easiest way to do this is you can look a little bit online before you do the integration, but like really before integrating them, I'm going to interpret that as before like committing to integrating them, right? Because you kind of need to try it out in your app to really understand deeply. So there's a bunch of different steps you could take here. The easiest and most lightweight is take before and after traces. Wrap anything, if they don't have tracing inside of their library already, then wrap any calls that you make into them. And just do a little bit of visual diffing and just, do a really quick stiff test of just saying, does this seem like it's doing something really inappropriate or slowing my startup? Or do I see these big giant blocks of I'm doing some crazy initialization during app startup that probably should be deferred? I would say those are the first steps that I would absolutely take. And you can write a benchmark for that, but again, if you have an ongoing startup benchmark, then ideally that would capture it. You can also look at the size of your application as kind of an indicator of as another sort of separate indicator of how much overhead that this thing is going to cause in your optimized R8 build, your release build. Those are the two places that I would start first.
Carmen, did you want to add
My
to
mic
that?
won't unmute. We're both having this problem. Yeah, I wanted to just emphasize the last thing that Chris said, which is to make sure that you are using R8 and optimization when you're evaluating the performance of these libraries, because if you're only using a small part of the library, but you don't optimize, then you might test it out and it might look like it has a huge impact, but then with optimization, a lot of things can be stripped away.
The other thing I wanted to add is that we also have this API called App Start Info, which basically helps you once you potentially decided to integrate that third-party SDK, you can run some A/B experiments to see whether or not your startup time actually does increase. And also you can decide to maybe not initialize this SDK in certain periods of time, such as if it started because of a background process.
Absolutely. And for the App Startup library, what that does, it gives you a way to structure this. So it's a bit misunderstood because some people say, oh, what does it do for my app startup? It doesn't make it faster. It just helps you to say, first initialize this, then initialize this, then initialize this. And it helps especially with things like content providers and was originally used for Work Manager and Hilt and things like that, so that they actually get initialized in a specific structure.
And just to clarify, that's the startup library, not App Startup Info.
Sorry, yeah, it is the startup library. We have another API that's called the App Startup Info, which goes closely with App Exit Info and also with Profiling Manager. So those help you to collect data from the field, whereas the startup library helps you to make your app start more structured. Since we just touched briefly on R8, I would like to take another question now. And you basically said that R8 makes the library smaller only if optimize is enabled. So with R8 enabled, do the ProGuard files still matter? Are they still relevant?
I want to chime in on that one. It's in some cases. So in the ideal world, it's not. So if you go and look at a sample app like now in Android, you can actually get away with not having any ProGuard rules file. So what happens there is that all of the libraries that you use, they have or they ship with or distribute keep rules. So these keep rules are automatically included in your build. So as long as these libraries specify the reflection in the libraries, and your own app is not doing any reflection, then in principle you don't need any ProGuard or any keep rules on your own. However, often your own app is doing reflection, and in that case you need your own file to specify that. And it's also not unusual, unfortunately, that third-party libraries, they ship inadequate keep rules, for example. So in that case, you may need to include some rules in your own file. In that case, obviously, I would recommend that you file a bug on the library so that we can get these issues resolved.
And one thing with that, and enabling R8 isn't just enabling R8. We have recently found that a lot of people are using a file, which is the default file, ProGuard Android TXT. That file brings in a flag, which is called don't optimize. And you can guess what it does. It just disables optimizations. And by just flipping that switch, we've seen a huge performance gain from that. So if you have that, you can check it either in your build Gradle file, or also in the configuration output of R8. We have all of that listed in the blog post, in the newly updated guidance. Make sure to check out what's going on there, and then when you figure out what's going on, then you can create a new release, roll it out to your users, and see what the benefits of that are. We do have another tool that is really important for performance optimization. It's a bit older than we've talked about it for a little more time than about the R8 performance improvement side of things. Is baseline profiles. There's a question here, and it's our baseline profile generation is flaky because it runs on production with dynamic content. Should I generate profiles in a stable test build with stub APIs and static content instead? I think that might be for Chris.
Yeah, so I think it's really up to you. Ultimately, if your baseline profile generate, like it is expected that if your content changes, that your baseline profile will change. If you have, completely dynamic list view of some kind that says, hey, there's 20 different items here, and depending on which ones are relevant, they may or may not show up in your baseline profile, then yeah, it's going to be inconsistent, but I wouldn't call that flaky in the same way that a correctness test is flaky, because it's kind of what you get out of it. Is it worth it to write those, to write that that fake data that says, hey, just load one of each of these views to try and capture all of those inside my baseline profile and make it consistent? I would say in a lot of cases it is. It kind of depends on how important the consistency is to you, because very small changes to your baseline profile are not going to make a massive change in the performance of your app, either in startup profiles or in baseline profiles, if they're relatively small. But if this is like the hero screen on your app, if this is like, this is the feed that makes your app what it is, then it's probably worth doing.
There is kind of a follow-up question on that. That is, can we baseline profile the entire app path? So to me, that sounds like a question. Should we create a baseline profile for everything within our app?
Yeah, please don't.
Yeah, so we actually once did this. It was called Android M. So basically what this question is, I think is very good, because like intuitively, if we say, hey, add stuff that's important here, because it makes things faster, why shouldn't I just add absolutely everything? And like, it's a legitimate question. Like, why wouldn't we want to compile everything? And the answer is that there are big trade-offs here, both in terms of memory usage, disk storage, and in terms of app compilation time, that you have to make here when you compile more. Back in Android M, correct me if I got that wrong, we had everything, the framework, whenever you would take an update to either an app or the framework, everything would get recompiled. So an app update, app is fully recompiled from scratch. Framework update, every single one of your apps is compiled from scratch. And it was a massive, massive drain on disk space, because compiled code is way larger than DEX. It was a massive slowdown in time, because compilation was happening on the device. And that's why we've moved so far away from that more recently. And in reality, I think you're going to find something like an 80-20 rule here, where you see that like 20%, that we're compiling 20% of your application gives you 80% of the benefit, or probably more, because the vast majority of the like corner cases of your app are not super performance critical, and don't need that compilation. So that's why we say don't compile everything. It's profile guided optimization for a reason. We want to say only compile the hottest paths.
And I'd like to add to that kind of a reminder that when you add paths to the baseline profile, you're kind of guaranteeing that those code paths are always compiled. Those are part of the baseline. These will be compiled from installation onward. However, the Android platform also continually builds a profile for an individual user as that user uses your app. So if you leave something out of your baseline profile, and that happens to be the code paths that the user enjoys using, those code paths will get added to that user's personal on-device profile. And after the first instance of them using it, the first day of use of that code path, it will be compiled just like the rest of the code in the baseline profile. So the baseline profile, it's important to include the most important paths so that their performance is always good. But like Chris said, if you leave something out, it's not also that big of a deal. Those things will get incorporated in time.
One of the things that I usually say to developers when they try to understand what a baseline profile does user perspective wise, well, it speeds up quite a few things. And one of the things that many developers have seen, or many users have seen as well, is you scroll through an app and there is kind of that distinct stutter. And you scroll back up, you scroll back down, it's gone. And that is essentially just-in-time compilation doing its thing. When you use a baseline profile, that is gone because the baseline profile already has ahead of time compiled everything for you. So you don't really have to do that yourself. The user doesn't have to do it on their device, but you do that and take that on as ahead of time compilation. There's another thing that we don't have a question on this right now, but since we talk about profile guided optimization, there is another profile that is the startup profile. And I think it's super important to talk about that as well. Chris, would you be able to talk a bit about it?
Yeah, so startup profiles are another form of profile guided optimization, which is taking that most important code and a sort of generally what you think of as like kind of a subset of your baseline profile and say, this is the code that is the most important for my user's first interaction getting to the app. Apps are pretty big these days. I mean, they're tens of megabytes kind of, or like 10 megabytes, potentially much larger than that. And all that is a lot of data to try and not just load, but execute during the first beginning of your app's startup time, especially if you want to be going incredibly fast on incredibly low end devices. So what startup profiles allow you to do is say, this is the code that is executed for the very beginning of my app when my app is starting completely cold, and isolate that from the rest of your code so that it gets loaded first and it gets prefetched as the runtime sees that code at the very beginning of your app. So say I have just let's say I have a 10 megabyte app. If I only need 500 kilobytes of that in order to start up, it's really useful to be able to tell the platform, hey, this is the 500 kilobytes to load first. And that's exactly what startup profiles do.
Yeah, I just want to elaborate a bit from the compiler. Another thing that we use the startup profiles for is to basically guide the optimizations inside R8. So one challenge or one issue can be that R8 takes code that's normally only loaded after startup and moves it into the startup path, for example, by inlining or class merging, things like that. But when R8 has access to the startup profile, it will actually avoid these optimizations that could potentially regress application startup because you cause more code to be loaded. So when you give a startup profile, R8 won't take, say, a class that's only used after startup and move it into the startup path.
Thanks, everyone. Let's move on to the next question from the stream here. Can you outline the benefit R8 provides to an Android application size and performance during the build process?
Yeah, so let's see here. So basically during the, so I assume that this is for apps that don't use R8, where you want to know how much R8 can sort of can give you?
As far as I understand it, it would be just outlining the benefits that R8 provides while the app is being compiled. Like, what does it do to make your app more performant? How does it do that during the build? At least that's how I understand it. If that's wrong, please bring it up in the chat, and we might be able to follow up on that.
Yeah, so I think R8. So basically, R8 will optimize your application. It will do lots of inlining, get rid of a lot of dead code. It will deduplicate instructions by outlining as well. So all of this sort of ends up not only reducing your size, but it also removes optimizations that the runtime would have to do. So the runtime would no longer need to do that inlining, for example. Yeah, I think that's sort of at least if I understand the question correctly. That's some of
I would say, yeah. So I think that the top 3 flags that R8 offers and supports inside of your keep rules files are a really great way to explain the 3 things that it does. The first one always, of course, being shrinking. Like if you cannot find a path all the way from one of the entry points of your application, if R8 cannot find that, it will just drop it. And that is a massive improvement to code size because like we were talking about earlier, a lot of times you only use a tiny portion of a library. If you get rid of all the rest of it at compilation time, that is a massive improvement in performance and memory. Another thing that it does is obfuscation or identifier minification. So that is shrinking all of the class names throughout your entire application and method names. All of those get so much smaller. And that is actually a large amount of dex. And again, shrinking, huge benefit. And then optimization has both class merging for reducing the overhead of the number of classes that you have. I mean, those of you that have been around in Android performance as long as I have may remember things like, oh, don't use enums because there's huge amounts of overhead to each class that you define. And like, that there is some non-trivial overhead to each class that you define, because it does take, more than a kilobyte or whatever it is for the runtime to represent that class. But what R8 can do is actually merge a lot of classes in a lot of cases, especially with things like lambdas and things that you don't even see or don't ever compare, in order to make fewer classes, optimizations that you don't even have to think about.
Yeah, enums versus intdefs, that was quite a conversation back in the day. I'm very happy that we don't have to do that for many developers. For folks like framework developers, that really matters. But for anybody that can use R8, it does not, because R8 optimizes it away for you anyways. It also takes all the beautiful MVVM, MVM, whatever patterns you use, and makes them all kind of disappear. That doesn't mean you shouldn't use them. It means you should use them because you are a person that has to write this, another person has to read the code. But the CPU does not care. We have another question around the app startup library that I would like to ask now. That is, when, in which cases, should the app startup library be used?
So the app startup library should be used if you have a really, really compelling reason to be initialized at the very beginning of application startup. And in almost every case, it is probably true that you do not need this. A lot of times, what looks like I need this to always be ready for an application in case they might cause it is actually like call this and use this thing is actually more of a justification for, okay, well, we just need lazy initialization and maybe, as early as possible, ask the application to, pre-init if they really care about this in the critical path. Because one of the common patterns that happens is that the more stuff that you do inside a large application that starts up at the very beginning, the more bloated and slow that startup gets. And it's really hard to tear apart over time. Like this is just true across every application, across the history of time, right? If you try and pull everything into the very beginning of application startup and your process lifecycle, it can make the later thing feel fast. But oftentimes you can get away with this by just optimizing your code, by prefetching this interaction, whatever this load is, and avoid the need for it. That said, if you absolutely do need to initialize at the very beginning to make sure that it is instantly ready, especially something that you know that you're going to be using during your first activity launch or whatnot, that's when application startup is appropriate. And certainly you don't want to have to be doing the content provider initialization trick on your own. That's how startup works. Android X.startup works. And you can just hook in with the existing one.
Thanks a lot for that. We have another question that is on Wakelocks. So how do Wakelocks impact battery? They don't seem related.
I think that's me. Yeah, that's a good question. I think that a lot of times when people hear about Wakelocks, they don't realize what it does, how it is associated with battery. So what Wakelocks are is basically a functionality to prevent the CPU from sleeping, especially when the screen is off. What could happen in this scenario is you might be holding this Wakelock that is application wide, device wide. And that means that other applications could actually be running processes that they wouldn't normally be able to run because the CPU would normally be in suspend, but because of the Wakelock, that allows other processes to run. So that could also cause processes within your own application to run as well. And from our own analysis, we have identified Wakelocks as one of the highest contributors to battery drain, though there are many other contributors as well.
I'd love to jump in on that one just to really emphasize the fact that Wakelocks are impact the entire platform. When an app holds a Wakelock, the door is open for the CPUs to be used, and other processes may use the CPU. So it's kind of a subtle, it can be hard to specifically characterize the exact impact of having a Wakelock open, because if you have it open by accident, for example, you might say like, well, my app's not doing any work during this time, so there's no battery cost. However, other apps may be waking up because the CPU is not able to enter suspend. The apps may be waking up and using that open door to do work. So Wakelocks are important, not just because of whether or not your app is doing some work during them, but because they're kind of like opening the barn door to anything happening on the CPUs during that time, if that makes sense.
Yeah, for sure. The one other thing I would like to add, since we've been talking about Perfetto as well, is this is a great time for you to actually just take a Perfetto trait and see exactly how much Wakelocks you're using, and also what the CPU or main thread is doing during the time that the Wakelock occurs. Because we have found, working with some partners, that they end up sleeping for quite a bit of time while that Wakelock occurs. So basically, you're not really gaining any value out of holding that Wakelock, and at the same time draining your user's battery.
It's like many other things when it comes to performance, a bit misunderstood. Many people are like, oh, it's really more of an expert topic. On the one hand, it is a bit of an expert topic in general, like Perfetto is, Wakelocks are, R8 is, everything is, until we actually talk about that. And that's why we're here. We want to talk and make sure that you understand what it's about. While you two were talking about it, I was thinking about it. It's kind of like having a car that's idling. It will drain the tank, but it's a car and drains the battery a lot faster because it's not just standing there. So it has to do something. So I hadn't thought about it that way before. So thanks. Please don't hold as many Wakelocks and test them. We all want bigger, better battery life, and you can help with that. We have another question that is on baseline profiles and production. How do you measure performance improvements after the app is pushed to production with a baseline profile? I think we can maybe baseline profile, but basically, how do you measure the performance improvement after an app is pushed to production? That is, I think, the core of it.
Yeah, this one is tricky. I could talk about a couple of ways. One thing, the easiest way, the lowest impact way, is and especially when we first started rolling out baseline profiles, this was my recommendation to a lot of app teams, is we would reliably see in apps field metrics, like what you can see in Play Vitals, that basic app startup times would be worse on the first day or two of an app rollout, and then they would normalize over time. So we would see this really characteristic kind of sideways hockey stick.
Yeah, inverse hockey stick, yeah.
Graph of every app startup where you do a release, it would start a little high and then it would normalize out. Start a little high and then it would normalize out. Without needing to add any additional tracking or metrics to your app, once an app rolled out baseline profiles, instead of seeing that very characteristic rollout over time, they would see a straight line. The first day of use would match the later days of use. And that's exactly what baseline profiles is supposed to do. It would not necessarily be something, without getting a little bit nitpicky on it, you couldn't necessarily see like what is the difference in numbers, but you could see that the first day of use did not match the later days, and then it started to match. So, that's honestly my recommendation for ease. Yeah, and go on, Chris.
Oh yeah, some of this has also changed over time. So on one hand, cloud profiles have gotten a lot lower latency, so you will see a lot less swoop on average. But that doesn't actually mean don't worry about baseline profiles. That's not important, because at the same time, baseline profiles got a lot better by supporting startup profiles. Startup profiles and pulling all of the important code to the first X file is something that can only be done at build time. Like, we have to do this at your build time. And so if you do that, you should actually see the minimum, the fastest startups go much faster, depending on how well that's working. Yeah. So like a little bit of this has definitely changed because of that. But the moment that you start using baseline profiles, you should absolutely be using startup profiles as well.
Yes, awesome call out. And startup profiles improve all of your app startups, not just the first day of use startups. So they're even more impactful in a way than baseline profiles. As far as just going back to the question, oh, sorry, Ben, go ahead.
Oh, no, but go ahead. No, please answer the question.
I just wanted to call out that one other interpretation for this question is like, I was kind of like, well, just look at the graphs. If you want to measure numbers, a good way to measure the numbers would be to use the application start info API, which on the platform side monitors, records your app start along with some breadcrumbs along the way. And then after the app is started at your leisure, you can query like, what did that app startup we just had look like? You can also query it during your app startup to kind of make decisions about what's going on during the startup time. Why am I starting up and so forth? But if you want to be logging and checking your app startup times to see if they're improving, you can query that application start info to get those numbers.
Yeah, and I also want to point out that we have Profile Verifier as part of the baseline profiles package, which allows you to look and confirm that profile compilation has succeeded. We have seen cases in the past where certain devices or certain configurations have had problems, but actually the most important one that I would call out is that sometimes you'll find that if you're using a DEX post processor or something like that, you might find that the baseline profiles that you've spent all the effort to build are not actually being compiled and installed at runtime. So you can see that in the field in production by using Profile Verifier, which will tell you, hey, are your profiles actually being compiled? And if you don't see an improvement with baseline profiles, this may be a reason.
Ooh, and one other thing is that I do want to acknowledge, maybe this is also part of the reason why the person asked the question, is both baseline and startup profiles are part of the APK that you put into the Play Store, which means that unlike a lot of performance improvements, you can't roll them out as a within APK experiment, right? So that makes it a little bit trickier to know what the impact is. You can roll out an APK versus APK experiment in the Play Store. It's kind of a pain. That's, I think, why all of our first instinct is like, here's how you can see if you compare release over release, what you should expect to see in your startup times between. Usually, I would say in the vast majority of cases, the improvement is something you can visually see, and it's not worth rolling out an APK versus APK experiment to validate. But it makes sense to do that, especially if you want to get those good numbers. And so that is how you would need to do it, is with the Play Store experiment in that way.
While on the topic of startup profiles, I just want to jump back to the first question, which was asking when R8 stopped being all about application size. So I think startup profiles is actually a very good example of that. So it's one of the few optimizations where we do trade some application size for application performance. So specifically, what we want to disallow optimizations that would improve application size but would regress application startup. So that's one of those interesting trade-offs in this area.
I mean, inlining as well, right? Like inlining is the classic one where a lot of times you'll have an incredibly important method that's called from 10 different places. It doesn't make sense to inline that from a size perspective, but it's worth it.
I think there's, for the measuring in the field, there's a couple of things that we haven't answered on that just yet. We talked a lot about baseline profiles, what those do, startup profiles, which are great. Like, I love all those things. I love the name that we used for startup profiles as well as DEX layout optimizations, because it optimizes the way that your DEX is put together. It's not arbitrary anymore, but actually, like, this is the stuff that is needed for startup, and that's being packaged in the first DEX file. But let's go back to how do you measure those things in the field? Like, how do you measure the performance improvements? We do have quite a few things on that. Alex, you wrote a blog post about measuring performance. Would you like to answer?
Yeah, specifically around measuring in the field. Yeah, so in my performance leveling guide, I have 5 different levels, and they start off with basically you don't have to do anything, it's done for you, which is Android Vitals, and it goes all the way up to very high effort. You'll need quite a bit of maintenance to keep this going, which is using creating your own performance tracking framework. And within the performance tracking framework, we have 3 different APIs for you to use. Application start info, which Carmen and I already talked about in previous questions, and also the profiling manager, which basically allows you to get those Perfetto traces that we found super useful, but in the field. So you can either define a trigger and endpoint manually, or you can define system triggered points for you to get those in-field traces. And finally, we have application exit info. So that helps you understand what are all the various reasons that the application exited, and it gives you a lot more in-depth information around scenarios where your application is killed suddenly. This can be native crashes or ANRs or LMKs, and you get like a lot more in that kind of dump of all of the various things that were happening in your application processes when that kill happened. Yeah, so would definitely recommend it for people who are more at that expert level in order to level up your metrics even further.
Absolutely, I'm fully with you on that. And getting started with Android vials is just the easiest one to get going, and then leveling it up from there. Make sure to read the blog post. I really love the way that Alice talks about it, kind of how you think about those things, because it's a question we get very often, and we hadn't covered it any other way. And that's one of the things when we hear feedback that we see that we haven't talked about, we try to either integrate it into the tools, into the guidance, into making sure that things get better for you as developers out there, that you have, on one hand, the guardrails, on the other hand, also the tools support you to do less of the things that slow down your app and make problems with your performance. Let's go for another question. We don't really have, we've been like 52 minutes now, which is great. And we have room for a couple of more questions, but let's go for one more from live chat. Is there any plan to add a trigger for all crashes, not just ANRs, to Profiling Manager?
Ooh, I love this. Yes, I would love to hear more feedback about which which crashes specifically are interesting. We're already have a few in mind that we're hoping to add. The trick to just adding a trigger for all crashes is that the debugging information that you may want for different crashes is different. So for example, one that we have the idea for is to collect a heap dump when the app has an out of memory exception, right? So the trace of what leads right up to the out of memory exception, in my opinion, is probably a lot less useful than the heap dump, right? The problem is not necessarily what just happened, but it could have been all the allocations that were made 20 minutes ago. And now what happened just now just put you over the edge, right? So when we think about adding these triggers, we're trying to be thoughtful about what information specifically is the most useful for debugging this crash. But long story short, yes, thinking about that a lot, would love, I love this feedback in general, and also would love more feedback in specific if there are specific crashes that, crash types that you are thinking about. Would love to talk it over with you.
Yeah, the other thing I would call out is that we are just very interested in feedback around Profiling Manager in general. So if you are already adopting it in your app, feel free to just come and send us a message either via the like social channels or in Slack. Yeah.
Yeah, absolutely. If you are adopting it, please let us know. I'd love to hear more about how it's going and what we can do to make it better.
Absolutely. Thank you so much for that, Carmen and Alice. I think we're nearing the end of the questions here. There's a couple coming in on the chat, and we might be able to answer them offline as well to some extent. But for now, the question I have here is, when setting up R8 in an Android project, which file is the primary place where you should define your custom rules to prevent R8 from stripping or renaming specific code?
I'll go ahead and say that I think it's important to keep it as close to your code as possible. So if you have 20 different modules that all comprise your particular application with a whole bunch of libraries and then just the application kind of as the last layer there, then keep that ProGuard file, that keep rules file, as close as possible to the code so that it's easier to see it alongside and move it alongside there when refactors need to happen. But the default template for creating, I know applications, I think libraries as well, will provide you a ProGuard rules.pro file. That's where you'd put it. In libraries, just make sure that you put that in the consumer rules. That's important to distinguish, and that's something that we've called out in the new R8 documentation a bit more, is clarifying the distinction between the consumer rules of a library versus the ProGuard rules, as it's called, which is the internal optimization if you are pre-optimizing your library. And
thank you so much for everyone. This was really, really very insightful for me. I hope everybody in the live stream loved it as well. We got a lot of questions. I'm very excited to see that we got to answer quite a few of them. And that's basically all the time that we have for the session today. Thanks, everyone. And thank you so much for the panels as well. And with that, I wish you a lovely rest of your day. Keep the questions coming, keep the feedback coming. Last thing that I want to say is, like Chris just mentioned, we have updated the guidance for not just R8, but pretty much a lot of the things. We continuously do that. And we've heard you that R8 guidance is a key thing that you wanted. And we have updated that dramatically. So if you go to developer.android.com/R8, you will find everything that you need to know on R8. If there's anything you missed in it, reach out. That's what literally, we want to talk with you, want to hear your questions, we want to be able to give you all the feedback.
Yep.
Absolutely. And with that, thank you so much, everyone, and have a good rest of your day. Bye.